Hey there, today we'll be doing this question that is validate stack sequences 946 on Leetcode, and the given question statement is given two integer arrays pushed and pop, each with distinct values, return true if this could have been the result of a sequence of a push and pop operation on an initially empty stack or false otherwise. So let's understand this question statement better. So first of all, they'll give you two arrays, one pushed and one popped. They try to mean that given this pushed array, can you get this popped array after doing some push and pop operation on this array itself? Okay, so let's understand this on how to actually build the intuition to get this done. Now we know that we'll be requiring some push and pop operation, so we can just definitely take a stack right here. Okay, and let's just move this stack to a better place. So it is here. Now, after this, we'll just start doing the operation and building the intuition right away. How to get it? Now, at first, we know we'll have to do some iterations on the pushed array and the popped array. Why so? Because we need to devise some push and pop operation in such a manner such that we do get this. Now, in order to do this, we'll be keeping two pointers, one on the push array and one on the pop array. Now, is the first element and the first element of both of these same? It is not. So let's just push it into our stack and let's just move forward in the push array. Now, is it same again? No. Let's just push it and move forward. We keep on doing this until we find that the pushed array element and the popped array element seem to be similar. That means whatever is at the top of my stack is equals to the popped arrays element wherever it is pointing to. Now you might think that what if we never find it? If we never find it, we will push every element into my stack and we see that we go out of the bounds. If that is the case, and we move out of our while loop, that is what we will be using here. And we can just simply say if my stack is not empty, then we know that we can never form this popped sequence. So now coming back to the original question that is right here, now we are at 4 and we see that in the popped array, where am I standing at right now? I'm standing at 4 itself. Now this, both of these are matching. So what do? We just simply make sure that we pop out this element from here. Now what do? Yes, we just move on to the next part. And remember to move from the popped array element as well, because we popped it out of the stack. Now we have what, 5. What do? We just simply put it here. Now we again match it. Is 5 whatever's at the top of my stack is equals to the popped array element? Yes, it is. So we just remove it and we move the j pointer to this one. Now we continue checking it. Now remember this checking part, that the top of my stack's element is equals to the popped element wherever it is standing at is similar or not, will be in a while loop. So we will keep continuously checking it, that is it similar, and we will just keep on removing the element. It was again similar, so we just move on. Again we'll check, is it similar? Yes, it is similar, so move on. Again it is similar, so we move on. So you see that we move out of bounds for the popped elements, and now you see that yes, our stack is empty. That means yes, we could do some push and pop operation which led us to actually form this popped array. So here we can conclude this, yes, this is a valid sequence and we can return a true. Now let's check on the implementation and everything will be clear to you. So with the implementation, we'll also just see the dry run right here. So let's just say 1 2 3 is your push array, 1 2 3, and let's just take a something simple, that is 3 2 1 right here. Can we get this or not? Now we see that at first I've declared right here ij pointers. Now what do? We put the I pointer here on our pushed array and the j pointer on my popped array. Okay, after that what do? At first we go into this while loop and we'll just push whatever the I value is pointing at, that is 1. Now what do? We just check, is 1 equals to 3? That means whatever is at the stack stop, is it equals to the popped array's value wherever it is standing at? If it is not, you cannot do anything, you just move I by 1. Now again we move I by 1, we are here, it is not equals, 3 and 2 is not equal, evidently move ahead. Again go on to this and push it here. Now we see 3 and 3 are equal, yes it is. Now that is the part where this while loop comes into play. Now you might think that are we traveling it n square times because it is a while loop has been nested? It is actually not. If we see, we are just traveling once only, because see here we traveled it once. Now we are just removing it, right? We are just removing it. So if we see carefully, we are just simultaneously maintaining two pointers. That means if it does matches that I and j, the values match, then what do? We just pop out and we just move j pointer, right? So this is what will happen. J pointer will keep on moving until it matches, and if you see, everything matches and our stack will be empty. So what is the total complexity going to be? It is going to be this whole array's length and this whole array's length. And since the lengths are similar, so if the length is n, so we'll be traveling it twice. So your whole complexity comes out to be O of 2n. And we could obviously take O of n because amortized, right? And we do not generally take the numbers into play. So this is the whole code. At the end of the day, we just check if our stack is empty, we return a true, otherwise we return false. And if you did understand this whole explanation, please do like. And if you want the code, it will be linked in the description as well.